Welcome to PALS. It's Professor Nyang's Anatomy Lecture Series. In today's lecture, we'll be looking at limbic system. If you're just joining us, you're watching our video for the first time, we will encourage you to be part of this great anatomy family where we make anatomy simple. In looking at limbic system, we are going to take it in two parts. In the first part, we'll be looking at the cortical components of limbic system. And in the second part, we'll be looking at subcortical components of limbic system and also the nerve fibers involved. So let's go to class. The term limbic is a Latin word that means limbus for border or edge. It also means ring. In our context today, it refers to those complex set of structures, brain structures, that are involved with learning, memory, and emotion. So what are these brain structures? They are cortical structures, meaning they are coming from cerebrum, and also subcortical structure means they are coming from below cerebrum that form a ring around the upper end of the brainstem and the diencephalon. Let's look at the diagrams we have. Now here, this part of the diagram is a sagittal section, and then we're looking at the medial view. The blue colored areas are the components that make up this limbic system. If you look at this diagram, this is a section of the midbrain. So we see these structures that form a ring around the upper part of midbrain and the diencephalon. So these structures make up the system called limbic system. This term was actually first presented by a man called Broca. So what does this region do? It separates the medial surface of the cerebral cortex from the diencephalon. Now let's also look at our chart. This whole area, this area also is the area of the brainstem. So what it does is it separates the medial area of the cerebrum from the diencephalon. The components of diencephalon are the thalamus, hypothalamus, epithalamus at the back, and all the rest. So this structure separates the medial surface of the cerebrum from the diencephalon, structures that make up the diencephalon. Now, if we group all these structures that make up the midbrain, then we can group them into telencephalic structures, diencephalic structures, and mesencephalic structures. The telencephalic structures are the cortical structures. The diencephalic structures are those structures that are from the thalamus, as you can notice here, hypothalamus here, epithalamus, and the rest of the structures that will come in the course of the lecture. Now, the mesencephalic structure is actually the midbrain. So these three main regions of the brain make up the limbic system. This system was formerly called the rhinencephalon because it was thought to be only associated with olfaction, but recent studies have shown that it does a lot more than olfaction. So at this stage, we'll generally look at the functions of limbic system. In the course of the lecture, we will break the functions into the specific regions of the limbic system. So generally, this system plays a role in the emotion of the individual, such as in fear, aggression, sadness. It also modulates such behaviors as feeding behavior, sexual drive, and motivation. System also has a lot to do with memory, retention of recent memory in particular, and then it also has to do with olfaction. As also a general view to the functions of limbic system, we can have the big 9 F's that can help us to quickly recall some of these functions. Beginning from here, we can see fear has to do with fight, flight, feeling, feeding, fleeing, fragrance, that's olfaction, fun, that is sexual behavior, flashback, that is memory. So it coordinates a number of these activities with other parts of the brain system. The limbic system can be classified based on their components. We have two major components. One, we have the cell bodies, which is referred to as the gray matter component, and then the fiber bundles, or the white matter component. Some of the examples of the fiber bundles of limbic system are the fornix, mammillothalamic tract, stria medullaris thalami, stria terminalis, medial forebrain bundle, anterior commissure, cingulum, and diagonal band of Broca. These are all fibers of the limbic system. Now we'll look at the gray matter components of the limbic system. This can be broadly divided into one, the cortical components, which are structures from cerebrum, and the subcortical components. And these are structures that are from mesencephalon and the diencephalon, structures below the cerebral cortex. We will further classify some of the components that are from cortical region. For this region, we also have three major areas. We have the limbic lobe, we have the hippocampal formation, we have the septal and olfactory areas. We'll try to identify them from our picture. For the limbic lobe, we have these areas forming the limbic lobe. This is the area of the limbic lobe, the area I'm running my light. Now the hippocampal formation, here we're looking at the structure here, we're looking at the structure here, and part of it up there. Now septal area and olfactory area, we're looking at the structures that are here and also here. So these regions make up the cortical regions of the limbic system. So this slide will give us a comprehensive view of what we have done so far. We started with the broad division of limbic system into the gray matter components, which are the cell bodies, and the white matter components, which are the bundles, fiber bundles. Now for the gray matter component, we further divided them into two: structures from the cerebrum and structures from regions below the cerebrum. These regions, which we refer to as the mesencephalon and the diencephalon. So here are the cortical structures. Under the cortical structures, we have these four areas. Structures that form the limbic lobe. We have the hippocampal formation, the septal area, and olfactory area. Then under subcortical structures, we have some of these structures that are forming this part of the limbic system, which are the amygdaloid nuclear complex, reticular formation, the hypothalamus, anteronucleus of thalamus, and habenular nucleus. We are going to go further to these components and look at their individual constituents. We will start with the limbic lobe. Recall that the limbic lobe is one of the cortical components of the limbic system. Now, the limbic lobe is a ring of cortex on the medial aspect of the cerebrum. It's part of cerebrum. Now, let's look at our first image here. In this image, we'll see the green colored area. This is a sagittal section of the cerebrum, and we're looking at the medial surface. So here, we are going to see structures along this region that is colored green. This region is the region that forms the limbic lobe. Now, this region is made up of four main parts and then two additional smaller parts. So we can say it has four parts. What are those parts? We have here, we have the part of cerebral cortex above the corpus callosum here, and we call this part above the corpus callosum, we call it the cingulate gyrus. Now we have the part within the temporal lobe. Here, we call this the parahippocampal gyrus. And we have this connection that joins both the cingulate gyrus and the parahippocampal gyrus. At this point, we call isthmus. We are going to use our next diagram to clearly show where we have the fourth part of the limbic lobe, which is the uncus. In this view, let us identify the other part we had already shown in the other image. Here is where we said is the cingulate gyrus. Underneath it is the corpus callosum. Now, here is the parahippocampal gyrus. Connecting parahippocampal gyrus to the cingulate gyrus is this point, and this point is the point that is called the isthmus. Now, anteriorly, we see this part of hook-like part of the cerebral cortex. We call this part the uncus. So, the uncus, the parahippocampal gyrus, the isthmus, and the cingulate gyrus make up the limbic lobe. These cortical areas are connected by the cingulum, which is one of the bundles of the limbic system. Now we're going to look at the different parts of limbic lobe. First amongst them is the cingulate gyrus. In this image, the green colored area here is the cingulate gyrus. Here is the corpus callosum, and this is the genu of the corpus callosum, and here is the rostrum. This is the rostrum of corpus callosum. Now, this structure begins below the rostrum of the corpus callosum and curves around in front of the genu and extends along the upper surface of the body. Here is the body of the corpus callosum, moves down towards the splenium of the corpus callosum, and this is the splenium of the corpus callosum. From here, it will continue as the parahippocampal gyrus, where it will be joined by the isthmus. Now, the cingulate gyrus has two parts. The two parts, we have the part anteriorly, and we also have the part posteriorly. Now, the part anteriorly is called anterior cingulate gyrus, and the part posteriorly is called posterior cingulate gyrus. The cingulate gyrus is the subject of many cognitive and neurocognitive studies. This is because damage to cingulate gyrus can affect our ability to respond to certain stimuli that will now result to abnormal behavior such as aggression, shyness, or even a decrease in emotional expression. The cingulate gyrus has also been implicated in Alzheimer's disease, anxiety disorder, addiction, depression, bipolar disorder, and schizophrenia. We'll look at the functions of cingulate gyrus and also the lesion. The cingulate gyrus coordinates sensory inputs with emotions. It also coordinates emotional response to pain, regulates aggressive behavior, affects maternal bonding, language expression and communication, and decision making. When we have lesion of the cingulate gyrus, these are some of the conditions that will be noted. One, we have akinesia, which is a movement disorder that is characterized by slow, repetitive movement. We also have mutism, which is inability to speak. We also have apathy, which is lack of motivation to do anything. In fact, it's lack of care and concern for whatever goes around the individual. And we also have indifference to pain. The next part of limbic lobe we'll look at is the uncus and isthmus. Again, let's go to our picture. Here again is the uncus. The uncus is the innermost part of the temporal lobe, and it is hooked-like in appearance, and this is also why it's giving the name uncus. The anterior segment of uncus overlies the amygdala. This around here is the point where we get our amygdala. Uncus is sometimes considered as part of parahippocampal gyrus. Now the next part of limbic lobe we'll look at again is the isthmus. This is also a cortical matter that connects the cingulate gyrus here with the parahippocampal gyrus here. It is considered a terminal part of cingulate gyrus. Now look at the last part of the limbic lobe, and this is the parahippocampal gyrus. Now parahippocampal gyrus is part of the cerebral cortex that is around the hippocampus. Let's look at the areas from our picture. Here is the hippocampus, and the cerebral cortex around it here will form our parahippocampal gyrus. This region plays an important role in memory encoding and retrieval. The septal nuclei are masses of gray matter that lie immediately anterior to the lamina terminalis and the anterior commissure. Let's identify these features from our pictures. Now, in the sagittal section, we are looking at the medial part. This is the corpus callosum, and here is the rostrum, and we have the anterior commissure here, where my light is, and below the anterior commissure, we have the lamina terminalis. So the region called septal region is on the medial aspect of the frontal lobe that is beneath the genu and the rostrum of corpus callosum. So that's the genu and that's the rostrum. So this septal area here is below both the genu and the rostrum of the corpus callosum, and it also has some areas. Let's look at our next image. Here, let's identify the structures again. Here is the rostrum, that's the genu. Here is the lamina terminalis. Now we have, and then this area is the septal region. Now septal region has some parts. We have some gyri under the septal region. The first is the paraterminal gyrus, and here is the paraterminal gyrus, this green colored area. Now adjacent to it is the next gyrus in this septal region called parofactory gyrus, and here is parofactory gyrus. Superiorly, the septal region continues as the indicium grisum. Here is the indicium grisum. The septal area is the pleasure zone of the brain. For the connections of the septal region, we will start with the afferent connections. Now these are connections that are coming to the septal region. Most of the major regions that connect to the septal regions are: one, the olfactory region, that's by means of the olfactory tract. Then the next is the amygdala. The amygdala connects to the septal region, and this is through the strata terminali, and also the hippocampus, and this is through its main efferent, which is the fornix. Let's look at our picture. In this picture, here is the septal region, and the first connection should be coming from here, which is the olfactory connection. Now the second connection is from the amygdala, and this is the amygdala. And we have a projection for the amygdala, which is the strata terminalis, which will run across the posterior aspect of the thalamus and then connect to the septal area. So the strata terminalis will connect the amygdala, and it will run this course. This is a part of the strata terminalis in the red dotted lines and connects the septal area. The second connection is the connection of the hippocampus. This is the hippocampus, and then the connection to the septal region is through its efferent, which is called the fornix, and then this is also part of the fornix. It runs this and runs this way, and then this fiber here, the lighter fiber, not the red one, will also connect to the fornix. So the hippocampus connects, this is the hippocampus, connects to the septal region via the fornix. The amygdala connects to the septal region via the strata terminalis. The major area the septal region connects to is to the habernular nuclei, which is part of the epithalamus. And this is the fiber through which it does that connection. and the name of this fiber is stria medullaris thalami. This is the point of a habenula nuclei. Now we look at the third part of the cortical component of the limbic system. And this part is the part we call the hippocampal formation. Now, hippocampal formation has so many components. The major components of hippocampal formation are: 1, the hippocampus itself, called the hippocampus proper. We also have the dentate gyrus, then the subiculum. Now, we have smaller components of this hippocampal formation, which are the indicium griseum, very poorly developed, the gyrus fasciolaris. Within indicium griseum, we'll be seeing these two fibers, the medial and lateral longitudinal stria. Here is the hippocampus proper, and part of the structure here is the dentate gyrus, and then the posterior part of the hippocampus is the area called the subiculum, and then the posterior part of the dentate gyrus will be the part that will form the gyrus fasciolaris. And gyrus fasciolaris will project backwards and continue as the indicium griseum. Within the indicium griseum here, we'll find the medial and lateral longitudinal stria. So for the hippocampal formation, we'll start from the indicium griseum. We'll also look at the medial lateral longitudinal stria, and then we'll look at the gyrus fasciolaris. The indicium griseum is the upper part of the formation. It is made by a very slim layer of gray matter that is seen at the top of the corpus callosum. Let's look at the indicium griseum. In this picture, we'll see here is the indicium griseum, and then we're seeing it above the body of the corpus callosum here. Now, within the indicium griseum, we see the two bundles of longitudinal running fibers, and these are the fibers that we call the medial and lateral longitudinal stria. So, above the corpus callosum here, we find the indicium griseum. Above the surface, it is actually not properly developed. It's part of the hippocampal formation that is not properly developed, and then within it we have the two fibers we mentioned, the medial and lateral longitudinal stria. When we trace the indicium griseum posteriorly, it will move towards the splenium of the corpus callosum, and there it will continue as the splenial gyrus or gyrus fasciolaris. This is the area we are referring to, gyrus fasciolaris. So we've seen the three smaller components of the hippocampal formation. We'll look at the next set of hippocampal formation. The structures we have there are the hippocampus proper, dentate gyrus, and subiculum. A transverse section through the hippocampus proper, dentate gyrus, and subiculum will give us an S-shaped appearance. In this image, we are looking at three structures of the hippocampal formation. 1 is the hippocampus proper, 2 is the dentate gyrus, and 3 is the subiculum. Now, this is the S-shaped appearance. This is the S-shaped appearance. Usually, this S-shaped appearance gives us the seahorse image that hippocampus derives its name from. Now, in this S-shaped image, we'll see the upper limb. This is the upper limb of the S. This is the middle limb of the S. And here is the lower limb. We'll see a fissure here. This fissure is called the hippocampal fissure. The hippocampal fissure will separate the upper and middle limbs of this S shape of the hippocampal formation. The superior limb of the S will form the hippocampus proper. Here we'll be looking at the superior part. This superior part will give us the hippocampus proper and part of the dentate gyrus. Here, this colored part here will give us the dentate gyrus, and the rest part here will give us the hippocampus proper. And now this upper part that gives us the hippocampus proper is also called the Ammons horn or Conu ammoni because of its resemblance to the horn of a ram. This deeper part here is the part that I said will give us the dentate gyrus. Is the part that is below the ammonous horn, and it will form the upper wall of the hippocampal fissure. Remember, this is the hippocampal fissure. Now, this part that forms the upper wall, that's the dentate gyrus, will be the one that is seen deeper and more medial to the conus ammoni here. The subiculum is the middle part of the S which connects the conus ammoni to the parahippocampal gyrus, precisely at the entorhinal part. And here we have this is a subiculum, this is a subiculum. Now the subiculum will act as a transition zone, and the transition zone is between the parahippocampus gyrus and the conus ammoni. Here is where the subiculum continues as the parahippocampal gyrus, beginning at the entorhinal region of parahippocampal gyrus. If we look at this other image, the image here, this is the conus ammoni, this is the conus ammoni, this is the deeper part, the dentate gyrus, and here we see the subiculum, and from this point we see the connection of subiculum to the parahippocampal gyrus, beginning from the first part of parahippocampal gyrus called the entorhinal cortex. The anterior end of the hippocampus gives this expanded notched appearance that gives the shape of a foot, as you can notice here. Now, because of this resemblance to a foot, it's also sometimes called the pes hippocampi. The ventricular surface of the hippocampus is covered by a layer of nerve fibers that will eventually form the alveus. The fibers of the alveus will move medially and collect to form a bundle of fibers. We are looking at this green part of the picture, and this bundle of fibers will be called the fimbria. The fimbria will project above the medial part of the hippocampus and run backwards along the medial side of the hippocampus to become continuous with the fornix. We'll look at dentate gyrus. The dentate gyrus is a longitudinal stripe of gray matter, and it is seen lateral to the conus ammoni. Its medial margin is free and bears a series of notches that give it the dentate appearance. Now, in this image, here we find the conus ammoni or hippocampus proper, and then within, medial to it, we see the medial aspect of the dentate gyrus with a notched appearance, as we can see here. We see the fimbria we just mentioned that will move backwards to form the fornix. When traced anteriorly, the dentate gyrus will continue with the uncus. Now let's see this in the next image here. Now, this is part of the dentate gyrus that will be traced anteriorly to continue as the uncus. Because of the close relationship between the dentate gyrus and the uncus, sometimes the uncus is regarded as part of the hippocampal formation. Now we'll just take a little look at the hippocampus proper. That's the hippocampus proper, and it gives a C-shaped appearance in a frontal section. The structure of the hippocampus is different from the rest of the cerebral cortex, because while most of the cerebral cortex is 6-layered, the hippocampus cortex is made up of 3 layers. It can be divided into 4 cytoarchitectural areas. We have the C1, C2, C3, and then the C4. The C1 is especially vulnerable to hypoxia. That's the C1 here. In the connections of the hippocampus, we have a number of afferent and efferent connections. The major afferent connection to the hippocampus is from the parahippocampal gyrus, which is from the entorhinal area. So for the areas connecting to the hippocampus, we have the entorhinal area, that's area 28. We have the olfactory cortex, we have the amygdala, the opposite hippocampus, and the parahippocampal gyrus. Now we'll consider the efferents of the hippocampus. For the connections of the hippocampus, the major efferent of the hippocampus is the fornix. The fornix connects the hippocampus to some of these bodies. 1, it can connect it to the opposite hippocampus. 2, to the septal nuclei. 3, to the anterior hypothalamic region, and to the mammillary body. Now from here, we can pick this is the hippocampus, and then we can trace the major efferent, which is the fornix. That's the fornix, the line in blue. Now from here, we're seeing the connection here is the connection going to the opposite hippocampus. That is, there will be a commissure, which is called the hippocampal commissure, or the commissure of the fornix, where it connects with the other hippocampus. Number 2, the fornix can move towards the anterior part and be connected to any of these 3 areas. Number 1, this one is going to the anterothalamic nucleus, that is to the thalamus. And then 2, this one is going to the mammillary body, that is hypothalamus. And 3, this one is going to the septal nuclei. For the function of hippocampus, it's involved in what we call FOS, that's formation, organization, and storage of memory. It can be referred as a memory indexer because it sends memory to appropriate part of the cerebral hemisphere for long-term storage and retrieving them when necessary. This is where we come to the end of this part of the lecture. We hope this material has been very useful to you. If you actually found it useful, we would love you to like our video and subscribe to our channel. Thank you so much, and see you in our next video. Bye for now.